Hey, well, hello, kids. Hello, period C. Here I am on a Friday night, but here you are on a Tuesday afternoon. And this is my second attempt to do this lesson because the first time I did it, I forgot to share the screen. Idiot. So now I'm sharing the screen. All right, so here we go. Tuesday, May 17th, day 2. Here's your video. And in this video, we are just going to discuss review. So nothing new here, just discussing. You will have a homework, and guess what? That's right, the math. The assignment's just called factoring. It's already posted now. It's due Thursday, 8 p.m. It counts as 2 homework assignments. Looks like we'll have our test on Friday because we drop tomorrow, and Thursday maybe do a little bit more review, and then we're good to go. Okay, so let's do a good job on the discussion, the review, and then you do your delta math when this video is over. All right, so what do we got? Let's start here. So the first couple were just GCF problems. What's a GCF for 3 and 9? 3. So 3 divided by 3 is 1. Still have the x squared. 9 divided by 3, 3. So it's 3 x squared minus 3. Remember, you can always distribute to check. Yep, 3x squared minus 9. Checkaroo. How about this one? What goes into 7 and 7? Just 7. How many a's can I take out? The smallest exponent on the a's is 1. The smallest exponent on the b is 1, leaving me with 7 divided by 7 is 1. There are 3 a's. I took 1 out, so there's 2 left. There's 1 b. I took 1 out, none left. 7 divided by 7 is 1. 1a, took it out. 3 b's, took 1 out, there's 2 left. That's your answer. We don't need to write these ones. It's not wrong if you do, but you don't need them. Okay. Hey, number 6, the answer is already there from my previous video. All right, so 15, 75, 25. You can take out 1m, 1n. 50 divided by 25 is 2. 3 m's, took 1 out. 2 n's, took 1 out. 75 divided by 25 is 3. 1m, took it out. 1n, took it out. That's it. That's it. How about one more? 6 and 9, 3, m1, n1. So 2m minus 3n should be it. All right, so that's just simple GCF stuff. Wait a minute, here's another one. A couple more, I guess. Yeah, let's just go right to number 10. All right, so what goes into 2 and 3? Just 1. Factoring on a 1 doesn't do anything for you. It doesn't hurt, but let's see. For a's, smallest a is 2, smallest b is 2, smallest c is 2. They both are C2, but that still makes it the smallest. 2 divided by 1 is 2. 3 a's, I took 2 out, there's 1. 2 b's, took 2 out, there's none. 2 c's, took 2 out, there's none. 3 divided by 1 is 3. And it's just going to be b, right? Took out both a's. 3 b's, took 2 out, so there's 1 left. C's are gone. Okay. So that is our straight GCF. Next, we go to difference of squares. Remember, to do a difference of squares, we need a minus. Both the 9 and 1 have to be perfect squares. Remember, our perfect squares, they're numbers like these. That's a 16, 36, 49, and so on. And the exponent has to be even. It is. So this qualifies. Just like this. 2 sets of parentheses, 1 plus 1 minus, doesn't matter which one you pick first. In the front slots, how do you get 9? 3 times 3. How do you get x squared? X times x. The back slots, how do you get 1? 1 times 1. That's it. That's it. All right, number 14 is a trick because 14 is not on a perfect square list. It cannot be factored. I'm not going to do that to you in the test. Every one of the tests can be factored. So I'm not going to spend time on that. Let's look at 16. Does it qualify? Minus. Coefficients 1 and 9. Yep. Exponents even, even. We're good. 1 plus, 1 minus. How do you get 1? 1 times 1. To get x to 4th, that's x squared, x squared. You basically cut the exponent in half. Divide the exponent by 2. 9 is 3 times 3. Cut the exponent in half. y1, y1. That's it. That's that one. And how about 18. 18, did you get A plus 3B and A minus 3B? All right, so that's difference of squares. Oh, there's more. 22 is a plus, not a difference. No good. 24 is A plus 7, A minus 7. 26, 2 is not a perfect square. No good. All right, I got one for you. How about 16 A to the 8th minus 25 y to the 24? Try that one. It qualifies a minus. 16 and 25 are perfect squares, exponents are even, so it does work. What'd you get? 16 is 4 times 4. The exponent just divided by 2. A4, A4. 5 5 is 25. Exponent divided by 2. Y12, Y12. That's it. All right, back to this now. Let's see. I want to go backwards to, where is it? No, I lost it. I know what I'm looking for. I'll tell you when I find it. Oh, come on. It's the ones you had to do a GCF and then difference of squares. I've lost it. I'm just wasting your time. What I was looking for is ones like this. Let's see. Oh, what am I doing? What if I gave you one like that? Okay, before we say, well, that's not a difference of squares at all. 12's not, 36 is, but oh, scratch that. Sorry, kids, I'm not thinking clearly here. Give me a sec. There we go. Okay. 12 is not a perfect square, neither is 27. The exponents are all odd, no good at all, but look for GCF first. Look for the GCF first. This, in fact, has a GCF of what? 3x. And once we take out the 3x, just by a normal GCF method, I get 4x squared minus 9. It's regular GCF. And now we do have a difference of squares. This does qualify 2x plus 3, 2x minus 3. So that's our entire answer. I don't know. Oh, look at Adeline when she was her first birthday. Let me see if I have this worksheet somewhere. There it is. All right, so here's some good problems here. Let's see. 3x squared y minus 48y. Okay, this one was on there. 3x squared y minus 48y. This was on the worksheet. GCF first, I can take a 3y. Leave me with x squared minus 16. That's a difference of squares, x plus 4, x minus 4. Okay, we got it. All right, next type is your trinomials, your MA factoring. And let's see, start with 42. Okay, this is the one where we multiply and we add. When we first saw these, we say, just choose that last number, multiplies to -5. Then we learn technically it's this number times this number, multiplies to -5 still, because 1 times -5, and adds to that number. Okay. So we talked about this a lot. If we multiply to a negative, it's going to be a positive times a negative. So what gives me 5? Positive 1, -5, or -1, +5? That's not a 5. That's a 5. Which of those adds to positive 4? -1, +5. So it's x minus 1, x plus 5. That's it. You can always FOIL it out to check if you want. Next one multiplies to 14, adds to 9. To multiply to a positive 14, add to a positive 9, it's a plus to a plus. So 1 times 14 or 2 times 7. It's that adds to 9, x plus 2, x plus 7. There you go. There you go. Is there more here? Yeah, there are more here. Okay, number 46 multiplies to 1 times 7 is 7, positive 7, adds to negative 8. I noticed in class the other day when I went around and helping you that a lot of you aren't writing down the M and A. Write it down. Don't try to keep it in your head. Get a lot going on in your teenage brain. So write it down so you can see it. Even write down the plus and the minus. So multiplies to plus 7 adds to negative 8. Okay. Which sign combination would it be? Well, it can't be a positive times a negative because a positive times a negative is a negative, and we want a positive. A positive times a positive is a positive, but positives added up don't add up to a negative. A negative times a negative is a positive, and 2 negatives added up is a negative. So that's our combo, minus, minus. So how do we get 7? It can only be -1, -7, and that adds up to -8. So that's it. A minus 1, A minus 7. And 48, did you get Z minus 5 and Z plus 2? Good. All right, then our last group is when the lead coefficient is not 1. So this is our magic. Theo, TO. All right, the MA in magic is multiplies to -10, adds to positive 3. So MA. All right, so this stuff we've done before. What multiplies -10? Going to be a positive times a negative, +1, -10, -1, +10. They're different. +2, -5. Oh, -2, +5. And that's the one that adds up to 3. So -2, +5 in the back, but the magic, the JIC part of magic is this 5 repeats, 5x and then 5x again. That's the magical part. 5x, 5 repeats twice. Then here's where the FIO comes up. You look for a GCF that I can FIO, factor it out. Is there a GCF here? No. Is there a GCF here? Yes. Can take it to 5, x plus 1. FIO, factor it out. TIO, throw it out. If I factor it out, throw it out. Final answer, 5x minus 2, x plus 1. You can always FOIL it to check, and it does, in fact, work. Let's see what else we got here. Let's see, 54. Let's go to 56. But you say, I want to know the answer to 54. Let me see. The answer to 54 is, let me see if I can do this one out. Yeah, I think it comes out like that. Yep. You say, how did you do that so fast? Well, I've been doing this since I was your age, but I won't be doing this much longer. The M multiplies to 10 times -1 is -10. Adds to 3. I feel like we just did this, didn't we? That was +5 and a -2. Multiplies to -10, adds to 3. +5, -2, magic, 10x repeats. FIO, can I factor it out? Yeah, I can take it to 5. 2x plus 1. That's a 2. Yeah, I can take it to 2. 5x minus 1. Factor it out, throw it out. 2x plus 1, 5x minus 1, and feel free to FOIL it and see if you get the right answer. And you did. You did. All right, how about one more? 58. 58 multiplies to 14, +14. How'd you get that? 7 times 2. Adds to +15. got to be a plus, plus 1, plus 14, plus 2, plus 7. I think it's this one. Positive 1, positive 14, and the 7 repeats, 7x, 7x. Can I FIO here? Nope. Can I FIO here? Yep, a 7. Factor it out, throw it out. So final answer, 7x plus 1 times x plus 2. 7x plus 1 times x plus 2. And I keep saying you can check these. Let's. 7x times x, 7x squared. 7x times 2 is plus 14x. Then 1 times x is x. 1 times 2 is 2. Collect like terms. What do you got there? You got 7x squared plus 15x plus 2, which was the original problem. So we're good. All right, kids, that's that. That's the review. Nothing new to learn, just more practice. Let me see if I have Google Classroom ready here. No. I just want to show you, no, I want rather the Delta Math thing. No, I'm not going to mess around with that. I will just mess things up. So the Delta Math is there. So now you can dumb the recording, do the Delta Math. I think there's a dozen problems or so. If you don't get it done in the CAF, it's homework. All right, kids, I will see you, not tomorrow because we drop. I'll see you on Thursday. Bye-bye. And goodbye. And end.